We're now going to get into Unit 5, which is going to be angles and parallel lines. The first lesson is going to be just a handful of different types of angles that we're going to use in Lesson 2. These angles are going to be complementary angles, supplementary angles, adjacent angles, and then vertical angles. So starting off on page 1, what I'm going to do is just quickly go over some of the different symbols you're going to see in this unit and just what they mean. So a point, right, is just a point with the letter. Okay. So the definition of a point, right, is just it's a particular place in space. Right, and its coordinate is x, y. Line, symbol, it look like a line with 2 arrows on the end. This is key. Okay. So a line is straight. No beginning. And no end. And a line is made up or has at least 2 points. Segment, just like a line, except it will have dots, or it can potentially have no dots. All right, and its definition is the same, essentially. So it's still straight, except it has a beginning, and it also has an end. And it's still, again, it's made up of at least 2 points. Array is what I like to think of a mix of a line and a segment. So it starts off with 1 dot, then it ends with an arrow. Okay, so again, it's straight, except array has a beginning. That's what the dot on the left means, but it has no end. And again, it's made up of at least 2 points. An angle is made up of 2 rays. And you're going to have at least 3 points. Congruent is an equal sign with the squiggly on top, and it just means the same or equal. Parallel, think of it as just like an equal sign. Okay, so parallel, it's from Math 1, never touches. Perpendicular is an upside down capital T with the right angle. And it just means 90 degrees. A right angle also means 90 degrees. But it's just an angle. Okay. So to name either a line or a segment, write the 2 points on the end and then put the symbol above them. To name an array, or an angle, list your 3 points, make sure the vertex is the middle point. So that's one definition that we didn't write. So I'm just going to come back up here and put an arrow to it. So your vertex is the point that's common to both of your arrays. So the next handful of pages is just, quick refresher on what things were. I'm going back and just doing some examples. So we want to list a type of figure that have the points X and Y in it. So X is my beginning, Y is my other point. So I have a end dot and an arrow. This is array, arrow, arrow, line, dot, dot, segment, dot, dot, segment, dot, arrow, ray, arrow, arrow, line, I only have one arrow, so this is array, dot, dot, segment, arrow, arrow, tells me it must be a line, dot, arrow is array, dot, dot, segment. So this one I have multiple pieces, but I'm just focused on X, Y, dot, dot. Tells me it's a segment. Again, I'm only focused on X, Y, arrow, arrow, line. These next couple examples, are they going to intersect? Remember, dot, 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 dot are endpoints, so that means you have what you have. So these are not going to intersect, right? If say I had an arrow here, that means it would keep on going up that way, so they still wouldn't intersect. Likewise, if I had an arrow here, they would keep going and never touch. So the only way these would touch would be if A had an arrow and C had an arrow.